So here is one of those lovely vector questions which involves ratio, finding unknowns. It's a tricky one. So have a read, pause it, I would have a go, and then watch some more. Right, I've popped some things on already. So we're told the ratio of O to n to b is 1 to 5. So if that's 1 to 5, then obviously n to b must be 5b. And we might as well find some other things that we can find. So for example, let's find a to b. So if I'm going from a to b, I'm going to go, so a, b. Now it's always a good idea to map out with the capitals. So from a to b, I'm going to go AO plus OB. So AO is minus 2A, and O to B, that gives us 6B. So that might be useful. Probably going to need it later. I could also find A to N minus 2A plus B. Yeah, using the same idea. And I guess I could find, what else? Maybe that's it for now. So I'm going to have a rethink of what the question is asking me. So I'm being asked to find this ratio of AP to P to N. So how do I actually get from A to P? So let's map that out using, again, use the capital letters. So I'm going AM plus MP. Now, do I know how to go from A to M? So A to M is going to be minus A, minus because you're going against the direction. Now, M to P, I don't know what that is. So what we do is we introduce this funny looking symbol, it's lambda, Greek letter, and it's lambda lots of MB. So I don't quite know what this bit is, but it's going from all the way across, and it's a little bit of it. So this lambda is saying we're just going to take a little bit of it. So we got minus A plus, now how do I go from M to B? And I go minus A, again because I'm going against the direction, and then all the way along the bottom, so plus 6B. Now, this is a bit of an A-level technique, but what you want to do is get your A's together and your B's together. So if I get my A's, let's expand the brackets first of all. Now hopefully you can see I've got these two A's which I could factorise out. Now notice I factorise out the positive A rather than a negative A. That's always a better way of doing it, which means I'm left with minus 1 minus lambda back on the inside, and then I don't need to do anything here because it's just B by itself. So that is my A to P. Okay, and that is sort of important, so let's just pop that in a little cloud. Now we could find A to P a different way as well. We could go down here rather than going AMMP, so we went before. We could just go and take a little bit of AN. So A to P is a little bit of AN. And now we introduce another funny symbol here, Greek letter mu. So mu and lambda, they are scalars. Okay, so they're just a number. Again, this is very much a sort of A-level technique. They're just a number of AN. They're a fraction of the amount. So I could go this amount of AN. Now I don't know what this amount is. So now I need to think about, well, how would I get from A to N? Now I worked it out, didn't I? Oh yes, remember? Over here, we worked out A to N. Yeah, that was minus 2A plus B. So what we're saying here is you can go from A to P this way, or you can go from A to P this way. Now they must be equal to each other because it's the same distance. Yeah, so these two vectors are the same. Well, if they're the same, then I must be able to say something special about that. So let's just play around with this a little bit, and we could say this is minus 2 mu A. So we underline the A and the B because they're vectors. So what we can say now is that this bit must be the same as this bit. Okay, so I'm going to say, I'm going to ignore the A's now, because the A is just giving me like the actual vector. I'm saying these two bits must be the same, because they're both an amount of A. So that bit must be true. And similarly, we could do it for the B's. Let's go crazy and have another colour. So now I'm going to do it for these two bits. So now I must be able to say, well, 6 lambda must be the same as mu. So now I've got two simultaneous equations, which I must be able to solve. So we could make this one slightly prettier and times it all by -1, which means you would get 1 plus lambda is 2 mu. We've got this 6 lambda here was mu. So we could say that 1 plus lambda must be equal to 2 lots of 6 lambda. Okay, so I'm just looking at, if mu is 6 lambda, then 2 of it must be 12 lambda. I'm picking up from here. Okay, which means 1 is 11 lambda. So an 11th equals lambda. And we're going to play around with that and find mu now. So we know that mu is 6 lambda from the above equation, which means mu must be 6 11ths. So we've got that, and we've got that. So I'm hoping we're pretty much there now. So we want A to P to N. Let's go back up and see what that actually means. Back to our diagram. So we want A to P to N. Now we said A to P was mu, lots of AN. Do we know what that is now? This is because we've worked out mu already. So mu is, what's mu gone? 6 11ths. Yeah, so this is 6 11ths, lots of AN. Well, if that's 6 11ths, then this bit must be 5 11ths of AN. Because you've got to have like one whole one, AN has got to be AN, so that's 11 11ths. And I want the ratio of A to P to N. So can you see that's just going to be 6 to 5? And that is our answer. So we go back down here and we got 6 to 5. I think that's a very tricky but lovely question.